tonight's homework is 36 through 92 even. Here's what's going to happen. I'm going to teach you how to do every section, okay, so that you know what you're doing on tonight's homework. I'm just throwing the notes out the window. This is a fresh, brand new, clean document, and I'm saying forget it. Because apparently you guys cannot do anything unless I take you by the hand and show you exactly step by step how to do your homework. I'm not your mom. But it appears right now that I'm not going to get out of this section unless I take you by the hand and actually wipe your face and spoon feed you the material. So that's what I'm about to do. I don't mean to upset anybody, but I'm being true statement here.
That's like the easiest way to learn.
No. In college, they give you the facts, and the homework and the facts generally do not match.
We're not in college.
I understand you're not in college, but my seniors, you are within months from being either graduated and going into the actual workforce or going to college. I wouldn't want it to be a rude awakening for you, now would I?
I got
In June? That means you really just need to, and I never have issues. You always listen to me and pay attention.
I listen.
Not a lot. Except for
You
what
staff
you
trust.
Hey,
Doesn't mean we don't listen. What do you want?
I witnessed the college homework from firsthand. My brother had to do like 5 sections in like 2 days, and there were 100.
And you want to complain about this assignment?
Yeah, that's why I'm going to college.
Okay, the first thing you need to know. S is equal to R times theta. S is equal to your arc length. R is equal to your radius. And theta is equal to your central angle. Do I have to tell you what this is? Do you have issues?
Can you just answer my question?
Nope. Nope.
Whatever, I won't do.
Your choice.
She said she grew out, but I know she couldn't start that.
That is your arc length. S is your arc length. That's your angle theta. And from here to here is your lovely little radius. You need to know this. This is a formula, just like the area formula of a triangle or rectangle or anything like that. I will show you where you need it. Patience is a virtue.
Wait, what's the
I'm
reason?
where we're reading it.
Radius is from the origin to this level little dot right here. See that? These are your radiuses. They're exactly the same. Okay?
That theta,
The central angle.
Is that can be the angle of degrees or the angle?
Whichever one is given, you're going to have to be able to transform. Get there in a moment. Okay? Now, I'm going to skip to this section of the homework. For those of us who are in third period, we need to listen to this one also because I didn't get this far with you guys, which is why I'm starting with this now. If we look on page 257, problem 78 and 80, this is find the angle in radians. Find the angle in radians. If you're trying to find an angle in radian measure, that means you're looking to have what in it? Pi. Do you need me? What do you need? Someone want to borrow a pencil back there? I am not having one up here. You have one?
Yeah.
Oh.
You joking?
Give him that one. Give that one back, Willie, and use that blue one that I just threw you. Okay, 78. Actually, 77 is what we're going to do.
Oh, this 78.
I'm not doing your homework for you.
Oh, it is a lot.
77.
Okay.
You have this lovely little picture. looks like that. You have 5 centimeters here, and then 6 centimeters out here. What they're wanting you to find is this theta. That theta, they want it to be in radian measurement. Do we understand that? So what was the formula I just gave you? S is equal theta times R, or R times theta, same thing. Okay?
No, I see.
Theta, I'm sorry? ETA. Okay? It's a Greek letter. Okay? Now, S is going to be your arc length. This is your arc length, which is S. This right here is your radius. So you plug in what you know. We know that S is equal to 6, and we know that R is equal to 5. Theta, we do not know. So plug in. 6 is equal to 5 times theta, divide by 5. And what is theta going to equal? Now, here's the problem. 6 over 5 is correct, but because we want it to be in radian measurements, we want an actual measurement in decimal units. 1.2 is equal to theta. 1/5 is the same thing as 2/10. Okay? Should we all understand that, yes or no? Okay? Now, if you continue on after that, you're looking at 81 through 84. It's exactly the same thing. They give you your radius, they give you your arc length. You need to find your theta. Do we understand that? For 81 through 84. And then they want it to be in radians. 1.2 already is a measurement, it's a decimal. So the 3.14 is not there because it's a decimal form. Do you understand what I'm saying? If you can plot it on a number line, it's in radian. If you can't plot it on a number line because you see a degree symbol, it's not radian. Are you with me? Okay.
Hey. Hold on. So go on the next one.
81 through 84 for the second time. We need to listen. The radius is R. They give it to you. The S is the arc length. They give it to you. The directions say find the radian measure of the central angle of a circle radius R that intercepts an arc length. All they want is theta. It's exactly the same as 77 through 80 without the picture. Is everybody with me on that? 85 through 88. Find the length of the arc on a circle of radius R intercepted by a central angle. These are exactly the same except for what is different. There's no picture.
Different formula.
They're giving you the radius and the central angle. What do you need to find?
Yeah.
S, the arc length. Now, for example, let's do 85. 85 is what? My radius is 14 inches, and my central angle is 180 degrees. Now, here's the kicker. You cannot do these problems when it's given to you in degree measurement. You have to transfer your lovely little degrees into what? Radians. So what is 180 degrees the same thing as? Pi. So now we have our lovely little central angle, and you plug into your formula. S is equal to R times theta. S we don't have. R is 14. Theta is pi. And literally take 14 times pi, and what does that give you? 43.98. That is your arc length. Do we understand that, yes or no? And the rest of them are all going to be application problems of it. Do we understand that, yes or no?
So do we need them in the decimal form then?
Yes, because arc length is a measurement, and a measurement means it needs to be in radian mode, which means I want it in a decimal. So you can get as close, because once you get past the thousands place, can you really measure any better?
No.
Unless you have a machine, you can't.
Yeah.
Does that make sense? Okay? So this is real world application problems, which is what we're talking about. All right, now let's go backwards now and start from the beginning of your homework assignment tonight. I started with the end to make sure that I got through the new material that you did not know yet. The rest of it, I've already taught you. It's a matter of you recognizing that I've taught it to you. Okay? So if we look at problems 35 through 36, 35 says to do what? Determine two coterminal angles in degree measurement, one positive and one negative for each angle. So if I'm at 52 degrees, I need to find my coterminal. How did I tell you to find coterminal angles?
Add 180 minus 180.
No, I did not.
That's not bad.
Minus 2 pi plus 2 pi.
Add 2 pi, subtract 2 pi if you are given the angle in radians. What are we given our angle in? Degrees, so therefore what am I going to do?
Oh,
I'm going to take my angle and add 360, which is going to be 412 degrees. And then I'm going to take my angle and subtract 360, which is going to be
Negative 308.
negative 308 degrees. Those are my two angles. Do we understand that, yes or no? So, if you need to, write on your paper, angle plus 360, or 2 pi, whichever it is, and then angle minus 360, or 2 pi. Do we all understand that, yes or no? That's what coterminal means. When? The arc length is still a length? No. The angle would be a negative angle measurement, yes. But if you can get me theta being on the unit circle, I'm okay with that. Okay? Yeah.
Okay, so you have one that's like negative 452 or something like that. So you need a positive and a negative. You add 720 to that?
You have to add until you get a positive angle. The question is if it's over 360 degrees and you still get a negative angle after you've added 360, how do I find a positive coterminal? You keep adding 360 degrees until you get a positive outcome. Does that make sense? If you can't get a negative outcome, keep subtracting 360 until you get the negative outcome. Does everybody understand what I just said? If you have an angle that's greater than 360 degrees, what does that mean? It's gone another revolution around, okay? 360 and 360 is 720. So if you have an angle that's bigger than 720, how many revolutions has it gone? It's now gone over 2 revolutions, and it's working on its what? Third. Do we all understand that, yes or no? But all of these are all angles that fall on the unit circle, which are going to be between 0 and 360. Does everybody get that? Excellent. Okay. Moving on. Going to problems 39 through 44. It says, find if possible the complement and supplement of the angle. You guys should be like jumping up and down for joy. Why should you be jumping up and down for joy? Because it's all in degrees. And since it's all in degrees, your brain's already thinking degree mode, right? So all you have to do for 39 is simply ask yourself, and I'm actually going to do 41 here. 41 and 39. 39 is 36, and 41 is 158. Now, if I want to find its complement, what do I do? 90 minus 36. If I want to find its supplement, 180 minus 36. Do we see that? Yes or no? Okay? This gives me its complement. This gives me the supplement. Now let's talk about 41. What's going on with 41?
Doesn't have a complement.
Why does it not have a complement? It's greater than 90 degrees. So therefore, whenever it says time to do the complement, 90 minus 158, none. Just put no complement, none. For the supplement, it's going to be 180 minus the 158, and then you can calculate it. Do we all understand this, yes or no? Moving on to the next section, 45 through 48. 45, the directions say, rewrite each angle in radian measure as a multiple of pi. What does that mean whenever they say as a multiple of pi?
You know, high track.
That means that they do not want a decimal. They do not want to measure it from 0 to 6.28. Do you understand that? The 0 to 6.28 is a measurement found on the x-axis, true statement. However, it's not asking for that. It's asking for you to keep the pi in there and to give them a fraction times pi. Do we all understand that? So all you have to do for 45 is simply do conversions. So I want to convert 30 degrees into what? So what am I going to multiply 30 degrees by to get a radian measure? Pi over 180. The degrees cancel out, and what are you going to have? Pi over 6. So for that whole section, what are you multiplying by for that entire section? You are multiplying by pi over 180 for the whole section. Do we understand that? Go to 49 through 52. 49 through 52, what are they giving you?
They're giving you the pi things, you gotta put it in.
They're giving you radians, and they want you to rewrite the radians as degrees. So if I'm looking at 49 and I have 3 pi over 2, what am I going to multiply that by to get rid of my radians and get degrees? 180 over pi, and that's going to give you 270 degrees. Do we all understand that? So for this whole section, what do I want you to do? Multiply by 180 over pi. That's what you're multiplying the entire section by. Do we understand that? Moving on to 53 through 58. Convert the angle measure from degrees to radians. Round your answer to 3 decimal places. Convert the angle measures from degrees to radians. Do they want pi in there now?
Not really.
No, they want a decimal. So they want you to actually use the 3.14. Do we understand that? It's exactly the same, but this time the directions specify no pi. You can tell that first period because this is exactly the same. The directions are very clear. Are they not? Make sure you tell. Yes, because she's going to have to fit. Okay, so if we're looking at problem 53. Actually, let's do 55. 55 is negative 216 degrees and 35, 216.35 degrees. Okay, so how do I make this into radians? Multiply this by pi over 180. And in your calculator, you're actually going to use the pi, which is 3.14. The pi keys in there. Can you see that? Oh, you guys are looking at me like I'm nuts. So if I take 216.35 and multiply it by pi, divided by 180, what do I get? 3.776. It wants that decimal because it's looking for a length. Do we understand that? Are we good? 59 through 64, convert the angle measure from radians to degrees. Round your answer to 3 decimal places. From radians to degrees. So what am I going to do for that section? So 59 is pi over 7. I'm going to multiply this by 180 over pi. So I come back over to my calculator. And I have pi divided by 7 times 180 divided by and does it really matter to have the pies in there? No, because what's going to happen anyway? They cancel out. I'm just making you see that. Gives you the 25.7. Okay, do we all understand that that's in now what measurement? Huh? Degrees. Degrees.
Oh, yeah, it is.
That's in degrees now. Okay? Moving on to the next one. In exercises 65 through 70, use the angle conversion capabilities of a graphic utility to convert the angle measure to decimal degree form. Round your answers to 3 decimal places if necessary. What this is talking about is degrees, minutes, and seconds. Also known as DMS. Also known as DMS.
So do you just write that like your machine, like in machining? Or do you
Yes, absolutely. Okay? Now, if we're looking at problem 67, that's 85 degrees, 18 minutes, and 30 seconds. Okay? And what it wants you to do is to convert the angle measure into degree decimal form. So what you're going to do is on your calculator, you're going to come over here, and you're going to hit the key right above the multiplication key, directly to the left of the number 9. To the right, sorry. Thank you. Directly to the right of the number 9. Do you see the second row, the second column? That is degrees, minutes, and seconds, right there. Hit enter, and that's what I want. And I'm going to type in 85, arrow to the right, 18, arrow to the right, 30, and hit enter. And it gives you the decimal. Okay? That decimal, I want everybody to come up here and check this out. Everybody on the calculator, go right up here by the X, by the battery, and click on that. Do you see what that tells you? It tells you what mode your calculator is in. If your calculator is in degree mode, you're not going to get the 1.48891. Whose calculator was in degree mode just now? What did you get?
85.3.
Now, this is the decimal in radian mode. If I come here and click on that and go to settings and go to general, and I change this to degree mode and hit OK, and I come back up here and hit enter, it's going to give me this fraction. If I want that as a decimal, okay. They won't let me do it like that.
You can go to menu, number, convert to decimal.
I know, that's the only way I'm going to go do it. Menu, number, and now convert to decimal. And hit enter. It gives you the 85.3083. Do we understand that?
So in that little box thingy on that button there, which one do we click?
Second row, second column.
Wait, we got 1.488, we got 88.
1.4889 is my radian decimal. 85.3083 is my decimal degree, not degree, minutes, and seconds.
So we need to change both.
Yes, it's going to ask you for which one. Now, the next set of instructions asks you to convert it from decimal degrees to degrees, minutes, and seconds. So what you're now going to do, are you ready? I want you to hit the book beside the 9 key. 2 keys to the right of 9. Hit the book. Is everybody in the book? This is what you should have in the book. Hit 2. Do you see how you have different menus up here? Okay? Hit 2. And in that 2, you're going to hit angle. And within that angle, you have to convert to degrees, go all the way down to your C's. Do you see convert to DMS? Hit convert to DMS, which is degrees, minutes, and seconds, and hit enter. And hit enter, and it gives you 85 degrees, 18 minutes, 30 seconds. And once you've done it once in your calculator, it automatically comes up again. So if I hit that book, and it already brings me where I was at. Okay? Do we all understand that? I have shown you how to do all of your homework tonight. True statement? You should not have any problems completing this assignment. Were there any questions over last night's assignment?
Oh, it was easy.
Are we good with last night's assignment?
I think it's the first time I did all the problems.
Okay. Tomorrow, we'll finish our unit circle. I'll give you the sine, cosine, and tangents. I'll just give you the sine and the cosine values of them, so make sure you have a unit circle with you. How many people in here have now gotten their sheet protectors for their unit circle? You guys need to get them. Rachel just said she got 20 of them per dollar. Does anybody want to give her one? Give her like a...
I don't think that.
That was nice of her.
I'll take one.
You getting tired?
Yeah.
Those are going to be your central ankle ones again. Okay. Honey, do you want to go home and cook dinner for me and go to a special ed meeting too? I honestly wouldn't want to go to your work either, though. I admit that.
I'm not sure.
Hold on one second.